different. All right, so what I want to talk about right now in tutoring is, again, some of the problems that I've been seeing in class that people are having as to know when different equations to use and for what times and what purposes. We have angles in different places on circles. So I'm going to summarize this as angle, position, and then the formula in order to find it. So essentially, if your angle is on the center, so that's the first one we're going to do. Angle on center of the circle. This one is very simple. We actually call that a central angle when the angle's on the center, right? And what do we know about the central angle in comparison to the arc it intercepts? It's the same as the arc. So the arc and angle are equal, right? And again, that's pretty much, I think everybody understands that one, if nothing else, right? So if that's x, this is x. Well, let me zoom in a little bit there. That's how far out I was. All right. Okay. So again, if it's on the center of the circle, that one's pretty straightforward. Then the second one that you have to deal with is when you have an angle on the circle. So on the circle. If the angle is on the circle, meaning the vertex of the angle is on the circle, then the angle is going to be what compared to its intercepted arc? Half. Yeah, so that goes for inscribed angles or any other angle that falls on a circle. So the angle will be half of the intercepted arc. Or if you wrote it the opposite way, talking about the arc will be equal to 2 times the angle, or twice the angle, double the angle, however you want to phrase that. So if I was to draw a picture, there's a couple different pictures you can draw for this one, right? We can do something like this, where we have an angle completely inside a circle, and we're talking about that piece and this piece here. Right? This angle is going to be half of this arc. All right? That angle is half of this arc. This angle is half of this arc. All right? So, for example, if I called this 2x, then this angle would just be x. All right? Now, again, this is an example of an inscribed angle. But again, it's for any angle that's on a circle. So you could even talk about one of the other properties that we had with an inscribed angle, where you have an angle inscribed into a semicircle, right? It's still an angle that's on the circle. So let me draw a circle, and then I'm going to draw the diameter. So it's going through the center. If you were to draw an angle here, this is automatically going to be a right angle, because this arc, all the way around, this arc is 180. Again, it's based off the same idea. If the angle is on the circle, it's half of the intercepted arc. All right, one other way that you could view this is that if you had a circle, and I'm going to draw the angle a little bit different this time. Let me draw the arc as well. Here's the arc. Up, you said? Yes. Even in this format, so now I have a tangent line and a chord forming an angle. It's still the same property. If this is 2x, then this is just x. So again, it's the same no matter what. If the Angle is on the circle. Now, there's two other places that you could have an angle. You could have an angle somewhere on the interior of the circle, anywhere but the center, but it also works for the center. So, again, anywhere on the interior, this next property works. So, angle position will be on the interior. So, on the interior of the circle. So, if we drew a circle, let me use a different color. Can you see this yellow?
Yes.
All right. So there's my circle. But then I draw angles that are formed by two intersecting chords. And these chords do not have to cross. Sorry, they don't have to cross at the center point of the circle. They can cross anywhere in the circle. They will form two congruent angles that are vertical angles, right? Now, using those two, in order to find those angles, we're going to use the two arcs that each of those intercept. So there's two separate angles that are both the same measure, but they're intercepting these two different arcs. In this case, the angle measure is going to be equal to the sum of these two arcs. So I'm going to call this arc 1 and arc 2. So arc 1 plus arc 2 divided by 2. Yeah, that's going to give us that angle measure. Huh? Whereas if it's on the exterior, when it's on the exterior, then the equation changes just slightly. And it doesn't matter how you draw this. You can draw this with secants, you can draw it with tangents, you can draw this many different ways. Alright? So it could look like this. Yep, sorry. Like that? Okay. It could look like this with two tangents, or it could look like this with a tangent and a secant. No matter what, there is an angle on the outside of the circle, right? The property remains the same. There are two arcs that are being intercepted in each case. In this one, we have this one, which is the big arc. I'm going to use capital letters to denote big arc. Again, we have the big arc. And this one we have a big arc. Now, for the other half, or the other arc, we have a small arc. So I'm going to use lowercase letters. This one is intercepting this one. This one is intercepting this one. Now notice, when it's two tangents, you're actually using the entire circle when it's two tangents. But again, the property holds true no matter what. The formula here is the angle is going to equal the large arc, big arc, whatever you want to call it, minus the little arc divided by 2. So in every single one of these cases, let me zoom out just a little bit. In every single one of these cases, there's something being divided by 2. The measure of the arcs are being divided by 2. If it's just one angle, right? If it's just one angle and it's on the circle, we just divide by 2. If you have an angle in the interior, you're going to have the two angles intercepting two different arcs. So now there's two arcs. Again, we're still dividing by 2, but we're also adding the two arcs measures together first. So the sum divided by 2. On the exterior, instead of the sum, it's the difference divided by 2. Right? The difference, right? Subtraction. But again, very similar formulas. But again, that's the difference as to when to use which of those properties. Again, if it's on the center of the circle, it's the same as the arc. If it's on the circle, then it's half of the intercepted arc. If it's on the interior, you could say it's the average of the two intercepted arcs, or you could say it's half the sum of the two intercepted arcs. For the exterior, it's half the difference of the intercepted arcs. But again, that's the difference between those properties. So again, I'll post these notes to Edsby as well, in case you missed something. Jay Drury also asked me to record this, so I'll post the recording of this. The other thing I want to focus on in tutoring today is the assignment that I gave in class today, which you said Ms. Oswald, I think, gave, was it yesterday? That was classwork today? Okay, so page 369 and 370, that's what I gave as homework today. I'd like to go through that because last week we spent a lot of time going over all the properties when it came to segments of a circle. This week we're focused all about the angles and arcs of a circle. So I think if I go through that, we should have a pretty good covering of all the material that you'll see on the test. Because we already talked about last Wednesday all the stuff dealing with the measures and lengths of the different chords and secants and all that stuff. But now we're talking about the angles and arc measures this time around. So let's go ahead and take a look at page 369. And I want to go through this with you guys. So if you've already started working on it, great. If not, again, you might want to follow along with my work. You might want to do the work on a separate sheet of paper so that you can try it on your own if you haven't already attempted it. All right? Again, if you're in my class, I don't care if you show me the work that you did with me, but you should probably do it on a separate sheet of paper. That way you can look back at it and try it yourself and then go check the work that we did in tutoring. All right? But again, if you show me the work that you did in tutoring, I don't care. It's the work. You'll get credit for it. All right. So let's take a look at, this is page 369. So on page 369, there's a lot of different things that they're asking you to do. All right. Again, this is going over all the topics that we had this week. So it starts off, we have some chords that are intersecting, and they're intersecting at the center of the circle. So we can use a couple different properties here. First, given a circle with the center C, so we know this is the center of the circle, SCR is 42 degrees. SCR. So that angle right there is 42. Now, actually, let me do one thing. I'm going to pause this for a second. Let me stop this video. I'm going to